Good morning, everyone. So let's start this warm up quick. All of this, everything we're doing today is help us to prepare for our test, which officially the test starts today, and then it's not due until um, Monday at 9 o'clock, 9 p.m. So you have plenty of time. You don't have to start it today, but it just has to, it's released today. And this is definitely one of the skills that will be on there. So what do we have? We have a table in weeks and then level. The table above gives the level of a person's cholesterol at a different time during a 10-week treatment period. What is the average, now that's key, average level over the 10-week period obtained by using the trapezoidal approximations with 3 intervals? So we know we have to do trapezoids. And really quick, if you don't remember trapezoid formula, that's something you definitely need to know. And they're telling me to go from 0 to 2. So if I'm picturing this, we don't have to make a graph, but I do know, and I actually kind of want to use this idea. This is the accumulation. So it's the sum of the areas from 0 to 10 of the cholesterol. They don't give us a piece, so I'm going to call this CT. C for cholesterol, T for time. But then they throw this word in, average, and that is overlooked often. That's our average value. So we're going to take our upper bound minus our lower bound and divide by that. All right, so this is really, in disguise, it's an average value problem with trapezoids. So I know that I'm going to basically take my answer, whatever it is, and divide by 10 or times by a tenth to get the average. But I have to then do base 1 plus base 2, and then the height in this case is the width between. So I've got 1/2 base 1 plus base 2 times the height. And there's the area of my first trapezoid. And then I'm going to do the next one. That's the interval from 2 to 6. And this one, if I kind of draw it quickly, it'll look like that. Its base 1 is 200. Its base 2 is 190. And the height is the difference between the x's, so 4. And I did not have enough room. Okay, and then we just got one more. We've got the trapezoid between 6 and 10. And that's 190 plus 180 times the difference between the x's, which is 4. And then I just have to figure out what each one of those are and add them up. So I know that, let's see, 210 plus 200 is 410, and then the 1/2 and the 2 are going to cancel out, so that's 410. Here we get 200 plus 190, which is 390, and then cut in half times by 4, or really just 390 times 2. And then same thing here. This is 7. Okay, and now once I add all that up, we end up with the total amount. Now let's think of that. This answer right here, it's a 0, is the area under the curve, or the total cholesterol levels all added up. But that doesn't really help me, right? And especially in the context of this problem, we don't really care about how much total cholesterol there was over a 10-week period. We want the average, and that's why we're dividing by 10. We're finding the average value of this. And the average cholesterol level over a 10-week period is right here. So they didn't ask me to summarize, but I think it's pretty important to kind of state what we just said. So if they asked me to explain this in the context of the problem, I would just say over a 10-week period, the average cholesterol level is 193, and then they don't have units. I mean, I don't know, are those cholesterol? You know, it's just that's a number that we kind of use to gauge cholesterol. Okay, so hopefully you're feeling confident in the trapezoidal approximations, and just be careful when you see that word average. It's kind of like dividing by the entire time period, in this case between 0 and 10, which is 10. All right, we have a test starting today that is available, but it's not due until Monday. I'm going to quickly just show you the slide. I will be posting these notes later on, so if you ever need to go back and look at them, you can. But we're just going to quickly talk about what's on the test. There's 14 questions total, and that's going to be worth 43 points. One of those questions, however, is the integrity statement. So you just true or false, you're going to do your own work. So, and that's worth nothing. So really, there's 13 questions total. 8 of them are multiple choice. 2 are fill in your blank answers. 3 of them you have to upload an image into Schoology. Okay, and this test is done in Schoology. You have to show your work for almost every problem. The ones that are really quick, I understand ones that you can look at a graph and get your answer. Those don't need work, but any problem that requires work, you should be showing work on a separate sheet of paper. And then when you're all done, you're going to submit all of that work to Schoology for a 7 points. And that's 7 summative points, which is a total of 50 points. So in the long run, this test is 50 total summative points. I'm hoping every single person goes to Schoology and submits that those points. So let me show you really quick what I mean, because every time we take this test or a test like this, some people don't do that. Now, you may have the options over here, like I have, or if you go under week 10 and Thursday, you have the test itself. So that's where you actually take the test. And then you have the worked out solutions. So this is where you submit the workout solution. The reason why we do this, 2 things. I want you to show work for every problem possible. And then if for some reason you don't get a chance to upload an image here, there's an error, I can't read it, I know you guys know how to submit them for sure as an assignment. And that's why I have you submit it twice. And I can't tell you how many times I have to go back and look at this because an image on the test didn't show up accurately. All right, so total of 50 submitted points. Topics, okay, what have we covered so far? Well, we just reviewed the trapezoidal Riemann approximation, but we had the left, right, and midpoint. Our big idea this unit is the idea of integrals, and integrals is the accumulation model, or the area under the curve. The reason why we call it the accumulation model, think about what we just did. In this example, we accumulated all of the levels of cholesterol, and that's what this answer was. 930 is the total amount of accumulated cholesterol over the 10 weeks. So that's what we mean by accumulation model. If you didn't pick that up. We talked about definite integrals. That's with our upper and lower bounds and how we evaluate that. We talked about properties of integrals. We had fundamental theorem of calculus. Part 1 was basically if we have a definite integral, you take the antiderivative and then evaluate the limits or the bounds on that integral. Upper bound minus lower bound. And that's kind of, hopefully that's natural progression. Now we've been doing that a ton. The fundamental theorem of calculus part 1 is the fact that an integral and a derivative undo each other. They're inverse operations. So we're going to review almost all of this today, but we'll definitely review this one specifically. And then we had motion problems connected to integrals. So we talked about position, total distance, and displacement. And then we also had average value versus average rate of change. We just saw an average value style problem in the warm-up today. We divided by 10 to get the average value of cholesterol. And then we talked about average rate of change. That's just slope, right? Rise over run, change in y's over change in x's. My big question, and I really hope you guys are following through on the expectations for Wednesday. Did you watch the video yesterday on Edpuzzle? If you did, it is a very good review for the test that you're going to be taking. So if you did not watch that video from yesterday, you should go back and do that before you take the test. And I'm giving you the strongest hint possible. You definitely want to go back and watch that. All right, so here's what we got. We're going to do a couple of different things. The first one, I want to make sure we go over the fundamental theorem of calculus part 1 on a problem like this. I took this right from a delta math problem that you had, and I just want to make sure we're comfortable with it. So I'm just going to go through this really quick. You don't even have to write it down unless you want to, but I'm going to go fast. So this is the idea of the fundamental theorem of calculus part 1 problem, which means a derivative and an integral reduce each other out. Okay? Let f be the function given by. So f is the area underneath the curve of this function t. All right? On which of the following intervals is f increasing? Now, here's how I think of this. We want to know when this function is increasing. Well, we know from first trimester that a function is increasing anytime its derivative is greater than 0. Okay? So what does that mean? That means I need to take the derivative of f of x, which means I have to take the derivative of this side as well. So I know that the derivative of f is f prime, right? And we want to know when that is greater than 0. And here's the part that you need to really connect with. When you take the derivative of the integral, these reduce each other out, and the fundamental theorem of calculus part 1 said there's a shortcut. We're going to take whatever this value is as long as it's the exponent. If the exponent is not on top, you need to flip the bound so it is, and we're going to plug it in exactly the way it is to wherever there's a t. So I got negative x squared plus, minus negative x plus 6. Now, I'm going to do this just so you guys remember, but you'll see it doesn't matter in this problem. I also have to take whatever this is, I have to multiply it by the chain rule. Right? We got to take the derivative of this x. Well, if it was something more than x, we would have a much more important value. But the derivative of this x is 1, which doesn't change this problem at all. All right, now, some people might forget about what did we do with the 6? The 6 has really nothing to do with this, because if 6 was to be plugged in, and then I took the derivative, it's a constant, and the derivative of that would be 0. So that constant has nothing to do with this. All right, so what do we need to do then? Well, we need to figure out when f prime of x is greater than 0, and to do that, we set it equal to 0. Now, I'm just going to rewrite this. If I had a number here, I would distribute it, but distributing a 1 doesn't change this. But there is one small problem. I don't love the fact that there's a negative here. So I'm going to divide everything by a negative 1. And now I'm looking for what are the factors of this. So we get a positive 3 and a minus 2. And then I can set those each equal to its own 0. Remember, these are the critical points that we found. All right, so I found my critical values, or critical points. What I need to do now is I need to test those into the first derivative to figure out which values are positive. So I'm going to test points to the left of negative 3 and to the right of positive, or in between these values. So I'm going to test, I don't know, negative 4 is a good test. And we're going to test it into the derivative. Now notice, I think by determining sign value, I'm going to use the factored form of the derivative, because remember, that's f prime of x, just to test. So if I plug in -4 here, I'll get a negative total answer. If I plug in -4, I get a negative. So a negative times a negative would be positive. And then I'm going to pick a very friendly value between -3 and 2, which is 0. If I plug in 0 here, I'll get a positive. If I plug in 0 here, I get a negative. A positive times a negative is a negative. And if I take a value greater than 2, let's say +3, +3 here will give me a positive value. +3 here will give me a positive. Positive times positive is a positive. So our answer, when is f increasing? F is increasing when the derivative is greater than 0. And here's the spots where the derivative is greater than 0. So my final answer would be, you should always go back to what function you're talking about, right? So f of x is increasing on the interval from -infinity to 3 to -3 and +2 to +infinity. And then my reason, why do we know that? Because f prime of x is greater than 0. Okay? Now you had problems similar to this, but they gave you a graph. And you were just, the nice thing about having a graph is you don't have to do any of the algebra. You just look for when that derivative is positive or negative, and that will tell you if it's increasing or decreasing. Okay? So hopefully that was a quick review, but it helps. What we're going to do right now is we're going to go into a little breakout room for about 15 minutes. And you've got 4 different problems on a slide. There'll be 7 different groups and whatever breakout room number you're in. So if you're in breakout room 5, go to group 5 on the Jamboard. And I'll send that link in a second. The problems. This first problem is just it's a little bit more complicated, but it is a properties of integral problem. This problem down below here is a definite integral problem where you have to do a little bit of work and then take the antiderivative. This one is the average value problem, and I just want to make sure you guys understand the notation. This x with the little notation here, it looks like a backwards, looks like an E, is the same thing as saying you want x to go from -π/3 to π/2. So it's just a different way to write your domain interval. And then here, this problem is, we know that this is the function f. We got to find the point, the derivative, and the second derivative of this given the graph. So we're going to have you work on this for about 15 minutes, and then we'll come back and we'll go over all these answers. All right, I'm going to throw you in the breakout rooms first, and then I will send this link so you guys have it. And the goal is to have you guys talk to one another through these problems. And I really don't care a ton if you write your answers on here. I think the reason why I want it to be a Jamboard so you can actually write on it is so you guys can talk to each other and help each other out. All right, so go to the breakout room, and then once everybody's in that room, I'm going to send you the link to open the Jamboard. All right, so if you haven't done so, please go to the breakout room so I can send this link. All right, Matt, Alyssa, you guys there?
Yep.
All right, you want to make sure you join the breakout room? Matt, you there? And I pre-wrote this out, so we're going to go through it step by step, but I don't want you to get too overwhelmed with this. So number one was a property of integrals. And let me try this just so we can better view. I think this should work. Okay, so what do you do first? We have to look at this integral. And notice, it's more than just the functions that are given. It's 4 times f of x minus 1. So I have to use the properties of integrals first and split this up. I'm going to take the 4 and move it out. And then I'm going to take the minus 1 and do that under its own integral. All right, and now I can focus on this part right here. What is the area under the curve from 2 to 5 of f of x? That's where these two given factors come in. So this is the way I think of it. They tell us that the area under the curve from 0 to 5 of f of x is 7. But, so we know that that's 7. We also know that the area under the curve from 0 to 2 is negative 3. And what we want to find out then is we want to find out what is it just from 2 to 5. So if you write out the meaning of it and substitute in, and then just move this negative 3 over, you find that the actual area underneath the curve from 2 to 5 is 10. So this piece is 10, and then we're going to multiply that by 4, because the 4 is a common multiplier. And then we have to deal with this part. What is the integral from 2 to 5 of 1? Well, that's where we actually have to find the antiderivative. So whose derivative gives me 1? It's x. Then we evaluate it from 5 to 2. All right, so 5 minus 2, 40 minus 3 is 37. So the overall answer for that one is 37. All right, let's look at the next one here. And I did some side work here, which might not be awesome, but if you look at the black portion that I have set up right here, average value, what did we do? We took the upper bound, which is pi, oh shoot. Why did I flip that around right here? This isn't right. Dang it. I don't know why I flipped those around. So this is going to be off. My blue number out in front is going to be off. This is your A and your B. So we have to flip those, and the B should come first. So we get pi over 2 minus negative pi over 3. And then if I'm going to combine those, they need the common denominator. So I'm going to times this by 3, and I'll get 3 pi over 6. That's the same as pi over 2. And then this is going to be a plus because subtraction of a negative. And then we're going to times this by 2. So I'll get 5 pi over 6. Which is actually, I think, what I had. Yeah, I don't know why I made that mistake. But now, this number right here is what we're putting underneath the 1. But instead of dividing by 5 pi over 6, I'm going to multiply by the reciprocal 6 over 5 pi. That's the same as dividing by 5 over 5. So then that's the average value part, right? The next part is evaluating the integral from negative pi over 3 to pi over 2. So whose derivative gives me sine? It's negative cosine. And then I have to evaluate it at pi over 2 and negative pi over 3. So I'm going to plug those in. If you need to, I did some little side work here, but I know that the cosine of pi over 2 is 0, so negative 0 is still 0. Cosine of negative pi over 3 is 1/2, and I kind of showed that right here with the unit circle. Or you can set up your triangle, but negative pi over 3 is just reflecting over, and the x value doesn't change, so it's still 1/2. And then I just have to multiply by 6 over 5 pi, and for some reason, yeah, right there, my final answer should be 3 over 5 pi. Now, I didn't tell you to. I was hoping, I guess I was assuming you'd do this by hand. If it's a multiple choice question and you're on the AP test and you're allowed to, I would use your calculator, right? Because once you get to this point right here, you can just plug all of this into your calculator and get your answer, and you'll be good. Okay, but this would be a no calculator question most likely. All right, let's look at this one. And same thing here. My intent was to have you do it by hand. I noticed some people just wrote the answer as a decimal, so that means they probably typed it in as a calculator. But what would we do? Algebra is your best friend, right? Rewrite this so you can write it as 3x squared over x plus 1 over x. So each numerator is divided by its own x. And then we can simplify. So I get 3x plus 1 over x, and now I can take the antiderivatives. I'm going to add 1 up here, so this will become an x squared. The 3 is going to stay, but if I put a 2 up top, I have to put a 2 on bottom. So I get 3 halves x squared. And then this is a big part. Make sure you check right now, did you say the antiderivative of 1 over x is ln of absolute value? You need those absolute value bars there. Otherwise, they probably wouldn't give you full credit. And then we're going to plug in e to both spots. Plug in e for both x, and then we're going to subtract, plug in 1. And what they're testing on this part is, do you know that the natural log of e is 1, and the natural log of 1 is 0? So then we get 3 halves e squared plus 1 minus 3 halves. Well, you can think of 1 as 2 over 2. 2 over 2 minus 3 over 2 is negative 1 over 2. So this is the answer we were looking for. If you did this in your calculator, which I was assuming you didn't, but if you did, it's equivalent to 10.584. Okay. All right, and then the last problem here. So this is the fundamental theorem of calculus, part 1. It says, here's f of x, okay? And the first thing they want us to do is find the point. So I'm going to plug in 2 right here for x. So I'm going to plug in 2 here and 2 here. Well, that's just 2 times 2, which is 4. And then we have to know, what do they mean? 1 to 2 of h of t dt, that's the area underneath the curve. So I can find the area of this trapezoid, which has a base of 4 and a base of 3. So 4 plus 3. The height is the distance of the x's, that's 1, and that's 7 halves. I changed 4 to 8 over 2, so then I get 15 halves. So that's just plugging it in, but knowing that evaluating the integral given a function is the area under the curve. Okay? But look at this one. Now they're saying find the derivative at 2. So I need to take the derivative of this piece right here. Well, the derivative of 2x is just 2. And the derivative of an integral, that's the fundamental theorem of calculus. The integral and the derivative cancel out, and the h just puts right in here. So here's the derivative, and then I'm just going to plug in 2 in for x. So it's literally saying do 2 plus h of t. Well, this is the graph of h of t, and I need to know what is h of 2. So I'm going to follow this over. What is h of 2? That's the point. H of 2 is equal to 3, because that's its output. And then we'll just replace that, and my answer is 5. Okay, and then the last one, how do we find f double prime? Well, here's the derivative of f. So I have to take the derivative of this blue piece, which is just h prime of x, because the 2 is a constant. So what does this mean? H prime of x is the slope of the graph of h. So it's the slope of this graph, so I need to figure out what is the slope at 2. If I plug 2 in, the slope at 2 is down 1 over 1, down 1 over 1. So the slope is just negative 1. So I hope that helped clear up some things. You could definitely see all of these problems on the test, so be careful. I want to show you this last problem here. because Mr. Waffler went over a problem very similar in the video. I just want to make sure you guys are super comfortable with this. And I would say this would be a calculator problem. Okay? On the test, there are ones that say no calculator, and there's ones that say calculator. If it says calculator, we're intending you to use your calculator, so don't try to do things by hand. All right, we're going to go through this really quick. Particle moves with a velocity modeled by this function v of t. It is also known that the position of the particle at time 0 is 23 feet. So what they're saying here is s of 0 is equal to 23. Think of that as this is where you start. You start 23 feet from wherever they consider 0. Okay, so that'll come into play a little bit later. All right, find the displacement from 0 to 7. Well, what do they mean by that? Displacement, and by the way, I'm going to go fairly fast, so you're not going to have time to write this down. But if this was a calculator problem, all you need to write is this. We know what v of t is, so you don't have to write it every time. But displacement is just how much time or space has gone between these. Yes, we could do this by hand, but I don't want to. I want to make sure you guys know how to do it in a calculator. So what I'm going to do is grab my calculator, and I'm going to plug in the function itself. And you're going to actually see Mr. Wathler did this, which I think is kind of a nice way to do it, is just plug in the function into y1. And we showed you this earlier, but if you graph it on a normal window, you can kind of see the velocity graph. So look at the area under the curve for the first 2+ seconds. That's negative. So you know you're moving to the left. And then everything after that point, you're moving to the right. And we're going from 0 to 7. Okay? So what would we do? Well, I want to go to the math button. I want to select option 9. I'm going to go from 0 to 7. Now here's the thing. Because we put this in y equals, I don't have to retype this. We showed you this before. You can go to the vars button and y vars, that's variables, and select y1. Okay? And there's your answer. So what does that mean? 134 point, I already forgot. 1/6 repeating. Okay. Now what is that? That's displacement. So that's how many feet we are from where we started. Right? So we are a positive 134 feet away from where we started. Okay. Now, what about the total distance? If I ask you to find the total distance traveled, then that. And notice they don't have to have the word total. It's just how much did you travel? We went from 0 to 7, but now we have to take the absolute value of that function. So I already have it in my calculator. I'm going to do the exact same thing, math math 9. The only difference is I have to now put absolute value bars, and we showed you that the other day. That's in the catalog. So second catalog, when you hit enter, now instead of retyping the whole thing, which you could do, I'm just going to go vars, y vars, first option is function, y1. And you can see those absolute value bars appear. So this is going to make everything positive. And notice this answer is larger than the displacement. That's because for that first 2 seconds on the graph, we were below the x-axis. So that's what this is going to be larger because we took that negative area and flipped up and made it positive. But we get 147.690. And that also would be feet, but that's our total distance traveled. It doesn't matter what direction you move. Displacement is where you end up. This is just your total distance traveled. Now here's the part that I want to make sure we get, because we didn't talk about this yet, is your position, but this was in the video. So if you didn't watch the video, this is new. Your position is your starting spot plus your displacement. So it's really quick because we already know the displacement and we know where we started. They gave it to us. We started 23 feet ahead, and all I have to do is add my displacement, and then I can get my final answer. So if I add 23 to this, what is that? 157.166 repeating. And this is my ending location, right? So your position is exactly where you are at the end, which is at 7 seconds. Okay? And then the last one is find the average velocity. I'm not going to actually do this one, but average velocity is just the average value. We're going to take and subtract 7 minus 0 of your displacement. So basically, I'm just going to take this answer right here in red and divide it by 7, or times it by 1/7. Okay. Now, the last part is we got to find the average rate of change. Okay, and this is the piece you got to know the difference between average rate of change and average value. Okay, average rate of change is just saying find the slope, and we know the slope is just your change in y's over your change in x's. So I need to figure out the difference of my x's, which in this case is t for time, and then I got to figure out what's f of 7 minus f of 0. So 0 is really quick. If I plug 0 in here, I get -3. And then I want to figure out what it is when I plug 7 in. And since I have my calculator, and I have it already in y equals, if I go to table, notice there's the 0, here's the 7. 7 is 40 or 74. So that becomes addition. 77 over 7 is 11 feet per second. Now notice, why is it feet per second? Because we took the change in feet, or the change in distance, over the change in time. So that is feet per second. Okay? And this answer here, the average value, would also be feet per second, whatever that answer was. Why is it feet per second? This red answer was the total feet that I went from the start, and then dividing by the change in the time. So average value is still in feet per second. All right, so hopefully that just gave you a quick review of motion. Again, all of these notes will be posted, so you guys will be able to look at that. So where do we go from here? What do we got? Well, turn in any missing work from this unit before you take the test. If you did not watch the video from Wednesday, you should go back and watch it from this Wednesday. In fact, you should watch all of the Edpuzzle videos from this Unit 6. On Wednesday, we gave you that review worksheet. Now, I'm not going to have you turn that in. However, if you do the review worksheet and the answers are posted in Schoology, you will be very well prepared. The video and the review worksheet will prepare you well for this test. So what do you have to do this weekend? You have to take the Unit 6 test before 9 p.m. on Monday. Okay? And some of you really have to get quizzes in, homework in. Some of us dug ourselves in a very deep hole for this unit, and this is our last big unit before we end the trimester. After this, we're going to do a mini unit on the rest of Chapter 6, but we only officially have, if you count today, we only have 12 days of school left. So some of you really need to make some changes, and it all has to be in before you take this test on Monday. Okay, I'll be available from 1 to 2 o'clock today in my office hours. If you need help going over any of this, please stop in and see me. Otherwise, the test is now active and you can take that right now if you wish. Good luck. Have a good one. We'll see you.